Lesson 4, we're looking at probably the biggest concept in physics, the concept of energy or work. We already said energy and work are very similar. Work is energy used for a purpose. And the concept of power, which we define as the rate of work or the consumption of energy over time, joules per second. So let's make a short summary of the concept of energy and power in space. In space, we said something moves, and we talked about charges, electrons or coulombs, and something pushes, we talked about voltage. When you have these two things, charge and voltage, then you have electric energy, Joule's law. If you divide the charge by time, you have current. So the electric power, the equation for electric power in electricity is voltage multiplied by current. And we have seen transformers are the systems that can step up voltage or step down voltage to increase or decrease current. When we talk about the element fire, we said many times that energy comes from the sun. So we define simply energy as heat that comes from the sun. There is an equation for heat there, change of capacitance by mass by change of temperature. And solar power is simply heat divided by time. The sun provides in 1 hour enough power for the earth to work for a whole year, for the humanity to power every need of energy for a whole year. On average, we get 1,300 watts per square meter from the sun. Every second we get 1,300 joules. Talking about air, we said the energy of the air has pressure that pushes and a volume that moves. That's known as Boyle's law in physics. And when you divide the volume by time, you've got the flow of the wind. So when you multiply the intensity or the flow of wind by the pressure, you've got the power of the wind. This is what pushes a windmill, for example, to generate electricity from the air. Same thing for air, water. Pressure and volume of water provide hydraulic energy. And when you divide that by time, the pressure multiplied by the flow of water, hydraulic pressure multiplied by the flow of water when you open the gate, to push a turbine in a hydraulic press, you got a flow of water and a certain pressure. The multiplication of these two factors give the power of the water. And Earth, we had potential multiplied by mass, gravitational energy, or gravitational potential energy. And when we go specifically to the Earth, the gravitational field of the Earth multiplied by the mass and the height provides the gravitational potential energy of the Earth, in planet Earth. When we divide this by time, height divided by time gives speed. Distance over time is speed. So the two factors that make the mechanical power are the force, represented by the weight, and the velocity. When you have, for example, a bicycle or a car, you can use a gear system to play with the power, factors of power, to increase force, sacrificing velocity, and vice versa. So basically, power has two factors, one that represents potential and the other one that represents flow. And transformers, electric transformers or mechanical transformers, or for example, the shape of the wing of a plane is a transformer of power in the air. Because the shape of a wing, I'm going to explain it very quickly. If this is the wing of a plane and it goes through the air that goes above the wing, let's say two molecules of air, A and B, are there, and they have to be there after the wing passes through them. But A has to cover more distance in the same time. So A gains velocity or flow, and B gains pressure. So this explains the upthrust of a plane. The concept of wind power is used to explain the upthrust of a plane. Same thing for mechanical gear systems. So this is just a revision of lesson 4, two big concepts with the equations.